Hello everyone, myself Alok Kumar. I am assistant professor in Government College of Engineering Dharmapuri. So here we will see next topic in second unit of compiler design. So that is predictive parsing. So here we can see predictive parsing is a special case of recursive descent parsing where no backtracking is required. Actually, we have seen recursive descent parsing also. In that backtracking is required, while in this predictive parsing there is no backtracking. So here this predictive parsing we can say as non-recursive predictive parsing. This one we can say as LL1 parser also. Okay, where LL1 means here in first L we can say as left to right scan, means suppose some input is there, then we will scan that one as from left to right. And the second L here, meaning of second L is like we are making one leftmost derivation tree, and here one is representing like look ahead, number of look aheads, means when we are checking whether the input is accepted by the predictive parser or not. So here we can say by checking only single symbol we can check whether the parser is going to satisfy that input or not. Okay, so here you can see like when we are checking whether the input is accepted by the predictive parser or not. So here with this algorithm or program we can check. So for that we should have that parsing table, okay, and one input also and one stack. Here initially we can say like at a stack, first top of a stack we can assume like X, that non-terminal is there, and initially we can assume like here one terminal is there, a terminal as a input in this input string like that. And here output we will get whether the string is accepted by the predictive parser or not. Okay, so this one is the algorithm to construct a predictive parsing table. Okay, so for that one input is required, that is grammar G. Okay, so here we will get one output, that is predictive parsing table, and this one is the algorithm, and we can say that this one is the method. Then how we will construct that predictive parsing table. Okay, so for each production, because we are taking one input as grammar, so here production rules will be there. So for each production, like if suppose production rule is like A is generating alpha of the grammar, to do the following, here these rules we have to follow, these two rules we have to follow. For each terminal A, in first of alpha we will add this production rule to this table M at this position where A is non-terminal and this small a is a terminal. So at this position we will keep this production rule. So in the same manner here second rule is there, if empty is in first of alpha, then for each terminal B in follow of A we will add this production rule to this position, okay, in that predictive parsing table. And one more also rule that we are saying in second rule itself, like if empty is in first of alpha and dollar is in first follow of A, then we will add this production rule, same production rule, to this position also where dollar is coming. Okay, so these two rules we have to follow when we are going to construct a predictive parsing table. Okay, and one more thing is, suppose some cells are empty in that predictive parsing table, at the time we will say that one as error. Okay, if you can see here, if after performing the above there is no production at all in this predictive parsing table, then set this one to error. Okay, by default we will say that one is error, suppose some entry is empty. Okay, so this one we can see with the help of one example we will see. Now you can see here this one is the algorithm to check whether the string is accepted by the predictive parser or not. Okay, so here one input we will take, that is a string W and a parsing table capital M for grammar capital G. Okay, and output we will get whether the string W is accepted by the predictive parser or not. Okay, so you can see here if W is in LG, that in that language, whatever language is there, okay, a leftmost derivation of W, either it will be created, otherwise error will come. Okay, if the string is accepted by the predictive parser at a time, leftmost derivation tree we will get for that input string W, else we will get error. Okay, so this one is the algorithm. Suppose here this one is let A be the first symbol of W, that input string, and X be the top of the stack symbol. So here we will check this algorithm. If capital X, we are saying this non-terminal, if this one is not equals to dollar is it's representing as empty stack. Okay, but if stack is not empty, so at the time here, if this condition is true, we will go inside of this one. So here we will check whether the non-terminal is equals to A, means then what we will do, pop the stack and let A be the next symbol of W. Okay, so we will move further to next symbol of that input string. Else if this condition is false, then we will go here. Else if X is a terminal, and if this is this non-capital X is a terminal, then we will say error. If again this condition is false, then here in this predictive parsing table, if an error entry is there at a time, we will say that one as error. Else if this one entry is like equal to like some production rule is there, like X is there at top of stack, and the top of stack can having some production rule like y1 y2 y up to yk. So at a time what we will do, we have to pop X and we have to push this full production rule in that stack. Okay, so here you can see pop the stack, like X we will pop, and push we will do in reverse manner, like yk firstly, after that yk minus 1, after that y1, in such manner so that y1 should be on the top of stack. Okay, and let X be the top of the stack symbol, already we have seen here. So this one is the algorithm, and with this we will see one example. So you can see here, this one is one example we will take here. So before this predictive parsing implementation, here 4 things we have to keep in our mind. So firstly, we have to eliminate left recursion, and suppose some grammar is there, we have to make that one as left factored grammar. Okay, and the ambiguity should not be there. Okay, left, that we have to eliminate ambiguity. Okay, so grammar should be unambiguous. Second is we have to construct first and follows for all non-terminals. Third step is construct predictive parsing tables. Okay, so here we will construct one predictive parsing table, and fourth one is here we will parse the string, whether the string is accepted by the predictive parsing table or not. Okay, so here one grammar is there. So with this grammar here we have to check whether first step. So here we can see here only left recursion problem is there, because here E is coming and here this first that is non-terminal is same as starting symbol. Here T is there and here T. So because of this one, this left recursion is there. So how we will remove this one, we have already seen in previous lectures, that algorithm, how we will remove left factoring. So okay, so here we will do E and TE dash, new non-terminal we are taking, TE dash will generate plus TE dash, and empty also it will generate. Okay, and here for this one over, now here we will see T will generate FT dash, new non-terminal we have taken, and T dash will generate asterisk FT dash and empty. Okay, for this one there is no any left recursion, so already we will keep like this manner. F is generating open parenthesis, E closing parenthesis, and second production rule is F is generating ID. Okay, so this grammar is free from left recursion. Okay, now we will find first. Okay, first we will find for each non-terminal. So here first of E will be, you can see first of T we will find. So first of T is first of F. First of F is opening parenthesis and ID. So here we will keep, but here F is not generating any empty, so here we will not move further. So here we can say T is not generating empty, so here we will not move further. So all we can say like first of E will be opening parenthesis and ID. Okay, now if we are finding first of E dash, so here E dash will be plus and empty. Okay, and first of T if we want to find, so here we have to find first of F, so that is opening parenthesis and ID. But here F is not generating empty, so because of that we will not find first of T dash. Okay, so here first of T will be opening parenthesis and ID. Okay, first of T dash will be asterisk and empty, and first of F already we have found, that is opening parenthesis and ID. Okay, like this manner we will find the follow of E, E dash, T, T dash and F. So okay, so here follow of E, you can see how we are finding follow of E. In right hand side we will see wherever E is coming, So based on that we have to find the follow. So follow of E will be first of this closing parenthesis. So closing parenthesis will come and E is a starting symbol, so dollar will come. Okay, you can see here. Now follow of E dash we have to find. Follow of E dash will be follow of E, and follow of E already we have found, that is all closing parenthesis and dollar. And here we can see E dash we have found. Now here in this one follow of E dash will be follow of E dash already we have found, so by default it will be same as it is. So you can see dollar and this one E and E dash both are same. Follow of E and E dash both are same. Now if you want to find follow of T, so how we will find follow of T? Follow of T will be first of E dash. So first of E dash is plus and empty. So here we can see plus is coming. Because of that here plus will come in follow of T, and here this one is empty. So here because of this one follow of T will be follow of E also. Okay, follow of E already we have found. So like this manner we can keep that follow of E and plus also, and here like this manner same this one is follow of T. If you want to find, then first of E dash you have to find. We have already found. Okay, so here it will come plus dollar and this closing parenthesis. Okay, now we want to find follow of T dash. So follow of T dash also we can find from this one. Follow of T dash will be follow of T. Okay, and that follow of T already we have found, and follow of from this one follow of T dash is follow of T dash. Okay, so this one we have already found follow of T, so same this one. Now follow of F if we want to find. So follow of F will be first of T dash. Okay, first of T dash already we have found asterisk and empty. So asterisk will come in follow of F. Okay, after that this one is empty, so follow of F will be follow of T also. Okay, so here we will keep that one asterisk and remaining follow of T, that one is this. So this like this manner we will find. Now we have to construct this predictive parsing table. So how we will construct? We will see, suppose here all non-terminals we will keep, and here all terminals we will keep. Okay, so here you have to see, like in first of E, this one is opening parenthesis and ID. So here ID and opening parenthesis we will keep the production rule from which this first of E came. Okay, so from this production rule it came, so here we have kept. Now after that for E dash if we want to find, so plus will come, so at plus we will keep this production rule. Okay, after that at this position you will see here empty is coming, so if we have to see follow of E dash, follow of E dash is dollar and closing parenthesis. So this one we have to keep, this one E dash is generating empty, this production rule we have to keep. Because of this one this empty is coming, so we have to keep at this place dollar and closing parenthesis. Okay, after that we have to find we have to keep this, see this T, so opening parenthesis and ID, opening parenthesis and ID. So at this place we will keep this production rule from where this first of T came, so FT dash. So, okay, so we have kept. After that T dash, so T dash is asterisk and empty, so asterisk we will keep, and follow of T dash we will find because empty is there in first of T dash. So at this place plus dollar closing parenthesis, this T dash arrow empty, this one is that production rule will come. Okay, after that here first of F, that is first of F, that is closing opening parenthesis and ID. Okay, so we will keep this at opening parenthesis, here we will keep this production rule, and ID we will keep F is generating ID, this one. So like this manner here this predictive parsing table we have constructed, and remaining empty entries are errors. Okay, so like this manner we can create predictive parsing table. So if someone is asking whether this one is LL1 grammar or not, given grammar, so here we can say all entries are having single all positions having, all locations having single entry. So here we will say this one is grammar is LL1 grammar. Okay, so now suppose here we are having one input and we have to check whether this input is accepted by the predictive parser or not. So how we will do? We will start from dollar at starting symbol, and input is this one, and dollar we will keep initially, and at last if $$ is coming, then we will say accepted by the predictive parser. This input is accepted by predictive parsers. Okay, so here we will see, we will check E over ID. Okay, E over ID in this position in this table, so E arrow T dash. Okay, E arrow T dash. So we will pop this E and we will push this T dash in reverse, so E dash T. Okay, after that we will see T over ID. Okay, so like this manner, T over ID F T dash. This one T we will pop, and T dash F we will keep, F over ID we will keep. We will check over F over ID is F ID. So like this manner, here we will pop F and we will replace F with ID. Okay, ID we will pop here. T dash we will see T dash plus we will see. So in this T dash plus we will see T dash empty is coming. Okay, so here T dash we will replace with empty. And after that, like this manner, here we have to do in same manner, and at last here we will get like $$ and $. Okay, so because of this one we can say the string is accepted by the predictive parser. Okay, if the string is not accepted by the predictive parser at the time, in middle we will get error. Okay, so this type of questions generally they ask in exam. Okay, so remaining topic we will see in next lecture. Thank you.